What's up, guys? Welcome back to LeetCode Path to Pro. Today is Wednesday, February 28th, hump day. I hope everybody's having a good week so far, and that, yeah. What was I gonna do? We stopped on this problem yesterday. Let's see if this is working right now. No. I think the issue comes down to how we're using our scene, right? So what are we doing here? So we have our queue, scene, append, start, best versus float. We pop if current and scene. If current and scene. Scene of current. Else we store it in there, right? If current and scene, but we still want to do this thing, right? And then we could continue, maybe? Well, okay, so scene of current. Because we just want to know if there's a cheaper way to get there. Price equals scene of current. Does that work? No. Okay. What if we don't do all this right here? Should be correct, yeah. Yeah. But I think it's gonna be too slow. Yeah. So if we just continue there, as we want. So we need to use this more effectively. Could we make this a list? I don't know how that would help us though. Right, like if we stored in our hash map, we stored like the key is um, the destination, like the current city we're in. And we stored all the info for like a node in the BFS. So we store the source or the city that we're in, the price, our current price, and our moves. Ooh, okay. What if we do this? If price greater than equal to, what about the moves? If price greater than or equal to scene of current, this might save us. And moves. Wait, what are we calling this? Stops. And stops. Alright, let's just try it with this. If price is greater than scene of current, then we just continue. Right? Because we've already seen we can get to that spot more cheaply. See if this works. Yeah. Dude, I'm the man. Fuck. I'm pretty psyched about that. Let me text. Let me text my roommate. God. Dude, fuck yes. That's hype. Right, so what we're doing BFS. So we have a queue. We have a hash map as our kind of cache. We're appending the first state is the queue, the first node. And so that's going to be wherever we start. We're keeping track of the price and then the moves, number of moves were made. Or I guess we're calling it stops. So I'm saying while queue, we pop left from the queue because we're appending. So you could append left and then just pop normal pop. It doesn't really matter. But then we're checking, okay, if this destination is in our hash map, then we'll go into this and we want to check if that current price, because this is keeping track of like the price of our current trip, how many flights we've taken and all that. If it's greater than or equal to the price that we have stored, we just continue, right? Because then we know based on our hash map, we've gotten to that same spot, but just more cheaply, right? Otherwise, we'll take the minimum of that, and I guess we don't need to do min here. We can just say scene of current equals price. Right, that should work. Yeah. Oh, we don't even need this. Wait, do we need this? Yeah, we'll keep it. Otherwise, if it's not, then we set that current price we've seen. If our current equals destination, we're keeping track of the best price. We'll set that to the minimum of itself or the current price of the trip. Then we continue to the next iteration because we've hit our destination. If the number of stops in this node is greater than k, we continue. We can't make that many stops. And then we just go through and append the next set of nodes to our queue. And then outside of that loop, we check if best price has been changed, if it's not that initial float infinity value we set. And I set that just because we're taking the minimum, so we want a really big number to guarantee that that gets changed. We just return that number, otherwise we return -1, which is what they say to do. So yeah. Bellman Ford. Yeah, that's what my roommate was talking about. I'm gonna post this, honestly. BFS with cache solution. Caching. What's the time complexity? What is the time complexity of this bad boy? Oh. Let's see what ChatGPT. It's not OV. It's not OV. Oh, okay, so that's wrong. So all we really need is OV plus E, and then for space, vertex plus edge. Yeah. It's OV for space. Yeah. What is this? This is a daily, I believe. What is this? This is a DP. I guess it is, yeah. Didn't really solve it in a dynamic way, kind of. BFS. And why we did BFS and not DFS? When you're trying to find the shortest route in something, or in this case, the cheapest route, right? Like when you're comparing paths to other paths, a lot of times BFS is better. For example, if you're trying to find the shortest path, right, you can think of like BFS is kind of gonna go out, like each tendril is gonna check every possible path, and when you hit the destination, you're guaranteed you know that first tendril that hits the path is guaranteed to be your your shortest path, because they're all at the same like iteration of length away from your source, towards your destination. Um, yeah, DFS is a lot. DFS is also, I'd argue more common and more useful, but I have limited experience, so take my word with a grain of salt. Um, but that's my experience. What I've seen, it's definitely more DFS. I guess on LeetCode at least, But BFS is pretty cool. I feel like BFS is honestly more. I feel like it's easier to implement. Maybe more code, but it's a little more, makes more sense in my head. So this is O of B plus E, and then we could possibly put every vector. We solved this. Pretty stoked. This BFS. I don't know. Cache. Or hash map. Called hash map cache. That was set. Time complexity. Intuition. E is flights. Approach. Approach. The approach. Yeah. Standard BFS. Use hash map to keep track of minimum price to reach the city. How many solutions are there? What do you got? Dexterous. All right, well, let's move on to. Let's move on. Put it in. Yep. Yep. Let's do today's daily. Hopefully, it's not brutal. Okay. Brutal. I've never solved this. It's good. Given the root of a binary, return the leftmost value in the last row. Ooh. Interesting. Ooh. Ooh. This is interesting. I feel like this is a really simple problem. This is backtracking, right? I think. I don't know if I've ever done a backtracking problem of my own, to be fair, so. I guess recursive is backtracking. I don't know. The tricky part is to know, like, how would you know you're on the last row? Well, alright, I can do that. So, if not root. How would we keep track of the leftmost? I think we want to pass in the depth. Yeah. Do something like that. Alright, so we have our DFS. That's in the root, the left, and the depth. Right? So if not root, return something like this. Leftness is 0. Depth is also 0. Return if root we do DFS root dot left. I guess let me check if left greater than result of 0 and depth greater than result of 1, then we set all right. Okay, and then we do our calls. DFS left plus 1, depth plus 1, root right, left stays the same, depth goes up 1. At the end of this, return. I kind of want to look at that DFS we just did. We're not returning anything, yeah. We should return. And then outside of that, we can just call DFS on the root 0, 0. Oh. For that one. Also fucks up on this one. Not root dot left. Well, that might be our spot. Well, let's see what's happening. Okay. One, two, four, 3, 5, 7, 1. F2. Oh. Well, wait. Let's see what result is. Why are these not getting updated? Oh, 224. Wait, what we really want to see is read out laughs. Or not. Root.val left in depth. So why is the depth of 7 less than the depth? Or do we just do that? Interesting. I'll go through. Fuck. How does it fail on this excuse? Oh. Last row. Oh, okay, yeah. If left. If depth. So we just need depth. Greater than equal to result 1. We also need to check if left. Just do a second if left greater than result. Where am I storing left? Oh god, I don't remember. 0. Something like that. Ah! Why does this not work? Oh. Short greater than. Output 0. Oh, because we're starting at 0. What did we set this to root of? Heck yeah. Cool. Not the prettiest thing in the world. But yeah. Not the prettiest. But it works. And I solved it, pretty quick, so I'm happy. Definitely not the fastest. Let's see what other people are doing. This is crazy. They have like pictures. Um, what? That's insane. There's no way this is it. All Q. Cause you're gonna pop left last. Oh my god. Yeah, that works. Oh, that's beautiful. Okay. I need to do more Bellman something. Bellman Ford. Or Bellman Ford. Or Dykstra. Or Ford. So this is just BFS or DFS. Yeah. I mean, I think this is a nicer solution. Alright. How fast is this? About the same. Um, yeah. Yeah. Cool. I think the BFS is a little bit cleaner. We did solve this one as well. So. Wait, why are they putting that in as a list? Do they say? Shit, which one is it? This guy, right? Yeah. Why is root past Q as a list? Oh, so I guess we could just do this, right? This is more my speed. Cool. Hey. Ah. So this is O of N, which are all the nodes, and O of M. This is a tree. Yeah. Let's see. See that rating go up. Hell yeah. Top 43. Get mediums. Let's go. All right. Cool. Well, yeah. Thanks for watching, guys. See y'all later.